Right, we're now going to have a look at some more difficult Hess's law questions. So if we look at this one over here, so what they wanted us to do is calculate the enthalpy change of formation of N2O gas. And they've given us these two enthalpy change of reactions for these equations over here. Now, what I've noticed over here in this question is that this bottom equation here is also the enthalpy change of formation of carbon monoxide of CO. Okay, so this one here is the enthalpy change of formation of carbon monoxide. We want to work out the enthalpy change of formation of N2O. So hopefully you can see that in terms of your Hess's cycle, it's going to be very similar to the ones that we've done before. I'm going to write that top equation as the one at the top now. Like so. And given that we've got the enthalpy change of formation of carbon monoxide, we want to work out the enthalpy change of formation of N2O. That means at the bottom I can just write elements and have my arrows pointing upwards. And if you remember, we don't need an arrow pointing upwards towards N2 because it's an element, or for carbon because it's an element. So arrow pointing upwards to CO and arrow pointing upwards to N2O. So this is the one that we now want to work out. We want to work out the enthalpy change of formation of N2O. We have the enthalpy change of formation of CO. So this one over here is minus 111 kilojoules per mole. And they've given us the one for this equation here at the top. So the reaction between carbon and N2O. So this one here is minus 193. Okay, so this one over here is now our unknown. This is our x that we have to find out. So now, given that this is the route that we want to work out, so we want to go from here to here, we can take an indirect route. So we can now go, so we want to get from elements to this at the top over here. So we can take an indirect route going from the elements to those products going back to our reactants. So we're going to go along this route, and that's going to equal this route according to Hess's law. So going across this route, so starting from our elements, going in the same direction of the arrow. So my calculator, I'm going to type in minus 111, so the sign stays the same if we're going in the same direction of the arrow. Now we're going to go in this direction, which is reverse of the red arrow. So I'm going to change the sign of this. So that becomes plus 193. And that gets us to our original reactants. If I plug that into my calculator, I get a value of positive 82 kilojoules per mole. And that's my answer for the standard enthalpy change of formation of N2O. Right, moving on to a slightly more difficult question. What they want us to do is fill in these boxes over here by looking at this data over here, and then eventually they want us to work out the enthalpy change of formation over here, so this reaction over here, okay, which is essentially the enthalpy of formation of calcium carbonate, okay. Right, so what we're going to do is we're going to look at filling these boxes in first. So if we look at this reaction here, we've got calcium carbonate reacting with hydrochloric acid to form calcium chloride, water, and CO2. What I've just said there is the same as this equation over here. So calcium carbonate plus hydrochloric acid makes calcium chloride, water, and carbon dioxide. And it's the same molar ratio as what we've got over here. So that means it's this exact number over here. So I'm just going to put minus 54 kilojoules per mole into this box here. Right, I'm going to look at this one down here now. Okay, so some of these things have stayed the same. So calcium chloride is here, calcium chloride is here. So that's not changing in this reaction. Water staying the same, water staying the same here. So in terms of what's actually reacting in this arrow here is carbon and oxygen to form carbon dioxide. So over here, that's referring to this equation here. So carbon plus oxygen makes carbon dioxide. It's the same molar ratio as what we've got down here. So that number goes directly into this box here. So that's minus 393 kilojoules per mole. This arrow over here, so again, look at what's not changed. So calcium chloride stays the same and carbon stays the same. Okay, so over here we've got H2 reacting with 1.5 O2 to make H2O plus O2. Or no, just H2O. Okay, so over here, that matches to this reaction over here. So H2 plus half O2 makes H2O. Okay, it's just we got 1.5 O2 here, so we do have an O2 left over. So that matches the molar ratios for that. So in this box over here, I'm going to write minus 285 kilojoules per mole. This one over here, so in terms of what's changing, or what's not changing, carbon stays the same and the O2 stays the same. So it's calcium plus hydrochloric acid makes CaCl2, so calcium chloride and H2. And that matches this equation here in the same molar ratios. So that means in this box, I'm going to write minus 168 kilojoules per mole. Okay. Now what we want to do, so we filled in the boxes, we now want to work out the value of this arrow here, the enthalpy change of formation of calcium carbonate. We can't do that directly, so we're going to take the indirect route. So we eventually want to go from here to here. So rather than going directly there, I'm going to take the indirect route. I'm going to go all the way down here, all the way across there, and then up to my product. So this is going to be my indirect route. Okay. So going down this arrow, I'm going the same direction of this arrow, so the sign stays the same. So that's minus 168. That gets me to here. I'm still going in the same direction of this arrow, so the sign for this stays the same. So that's minus 285. This one, again, I'm going in the same direction of this arrow, so that is minus 393. Now this one over here, I'm going in the opposite direction of this arrow to get to here, so I'm going to change the sign of this. That becomes plus 54. And then if I plug that all into my calculator, I get a value of minus 792 kilojoules per mole. And if this route is equal to minus 792 kilojoules per mole, that means this route over here, the standard enthalpy change of formation of calcium carbonate, is also equal to minus 792 kilojoules per mole.